Afternoon everyone, my name is MD Sakil Mondal and today I will be presenting on random signals and noise as a part of my analog communication course. In this presentation, I will cover the fundamental concepts of random signals, their types, statistical properties, power spectral density, noise and their impact on communication system. Let us begin. Random signals and noise play a crucial role in communication and signal processing. In real world systems, signals are often affected by unpredictable variations and noise, making it essential to understand their behavior. We will explore different types of random signals, their properties, and how they influence signal transmission and processing. Now we will go through the types of random signals. There are different types of random signals, including stationary and ergodic signals. A stationary signal maintains constant statistical properties over time, meaning its mean and variance do not change. On the other hand, an ergodic signal is a type of stationary signal where time averages are equal to statistical averages, allowing us to analyze it using a signal realization. For example, thermal noise in resistors and atmospheric disturbances in communication systems are considered stationary signals. Now we will discuss the statistical properties, mean, variance and correlation. Now let's look at some key statistical properties of random signals. The mean. The mean represents the average value of a signal over time and gives an idea of its central tendency. And the variance measures how much signal deviates from its mean, helping us understand its spread. And the correlation function shows how signal values at a different time of instances are related. This is useful in analyzing signal patterns and predicting future values. On the left hand side there is a picture of correlation where there is indicates the relationship between two sets of data of signals. Now we are going to discuss the power spectral density, which is a frequency content. So power spectral density or PSD describes how a signal's power is distributed over different frequencies. It helps us analyze a signal's frequency content, which is essential in designing filters and optimizing bandwidth. And there are some applications. PSD is used in a communication to figure out bandwidth needs and improve signal sending. It's also important for filtering out the noise. By looking at a signal's PSD, we can find the best bandwidth for sending data, which cuts down on interfaces and speeds things up. PSD also helps create filters that get rid of noise and pull out the important parts of a signal, making communication better. We are going to discuss the noise. Noise is an unwanted disturbance that affects signals during transmission and processing. It can degrade signals quality and make communication unreliable. Two important types of noise in communication systems are Gaussian noise and white noise. Now, Gaussian noise. Gaussian noise is named after Gaussian or normal distribution, which it follows. This means that most of the noise values are clustered around a central mean with variations following a bell-shaped curve. This type of noise is common in electronic devices and naturally occurs due to thermal agitation of electrons. For example, in resistors and semiconductor devices, thermal noise follows a Gaussian distribution. Gaussian noise is important in communication because it models real-world noise accurately, and many signal processing techniques are designed to reduce its effects. Now when we talk about the white noises, the white noises is a theoretical noise model where all frequencies contain equal power. This means it has a flat power spectral density, making it a broadband signal. While pure white noise doesn't exist in reality, many natural noise sources like thermal noise in circuits or background noise in radio communications can be approximated as white noise. White noise is often used in testing and simulation to understand how systems respond to different frequency components. Now when we discuss the impact of noise on communication, we can say that noise reduces the clarity of signals, leading to distortion, data loss, and errors in transmission. Engineers work on noise reduction techniques like filtering, modulation schemes, and error correction coding to minimize its effects. Now we are going to discuss signal to noise ratio. Signal to noise ratio, or SNR, is a crucial measure that determines the quality of a signal by comparing its strength to the level of noise. Now when we talk about the definition, SNR, or the signal to noise ratio, SNR is defined as the ratio of signal power to noise power, usually expressed in decibels. A higher SNR means the signal is much stronger than the noise, leading to better communication quality. Mathematically, SNR is given by SNR decibel. We can say about or evaluate is equal to 10 into log 10 signal power or noise power. Now when we discuss the importance about SNR in our communication systems, we can say that a high SNR ensures clear, distortion-free communication. For example, in mobile networks, a strong SNR results in better call quality and faster data transmission. In contrast, a low SNR leads to interference, making signals difficult to understand. This is why weak signals in mobile networks often results in call drops or pixelated video streams. Now when we talk about the real world example of SNRs, we can say that number one is telecommunication. Mobile phones and Wi-Fi signals require high SNR for clear voice and fast internet speeds. In number two, we can say audio systems. A high SNR in microphones and speakers ensures crisp, noise-free sound. We can also use the SNR example in image processing. In photography, a high SNR means less grain or noise in low light images. In summary, improving SNR is essential for high quality communication, and various noise reduction techniques are used to enhance it. Now when we talking about the real world applications in communication system of the signals and noise, understanding random signals and noise is fundamental in many real world applications, especially when we talk about the real world applications of noise and signals in communication systems. The concepts of random signals and noise are widely applied in various fields. In wireless communication, engineers used error correction codes and modulation schemes to counteract the noise. In digital signal processing, noise reduction techniques are essential in digital signal processing. Filtering and other signal processing algorithms aims to suppress noise and enhance signal quality. In photography, in image and audio processing, denoising algorithms enhance clarity in photos and noise, and also in sound recordings. Now, in the conclusion, to summarize, we have discussed random signals their statistical properties, power spectral density, and the impact of noise on communication systems. Understanding these concepts helps in designing effective signal processing and transmission methods. Looking ahead, advancements in noise cancellation and robust signal processing will continue to improve the reliability of modern communication system. Thank you for your attention. I am happy to answer any questions you may have. Thank you.